Hello learners, Mr. G here. I'm going to make another video about the atom, electron configuration, and the periodic table, okay? I apologize for my voice, it's a little bit sore, but eventually will be fine, okay? So this question it will help you for the coming control test. See which particles in an atom has a positive charge. Remember, atoms have three different types of particles, right? So atoms have three different types of particles. Those particles are protons, neutrons, and electrons. The protons are positively charged. The neutrons do not have any charge, and the electrons are negatively charged. So, recording that one and saying that, we can now answer this question real fast. What particle in an atom has a positive charge? And that will be the protons. Which particle in an atom has no charge? Neutrons. And which particle in an atom has a negative charge? Electrons. Alright, so that is the first answer for this question, and if you do it correct, then you will always get 3 marks. 1 mark for saying protons, 1 mark for saying neutrons, 1 mark for saying electrons. Well, question 1.2. Question 1.2 said lithium has 3 protons, 4 neutrons, and 3 electrons. Explain why lithium has an atomic mass of 7. Now, let's record that atomic mass the symbol is A is equal to the number of protons plus the number of neutrons. So, what is the atomic number 7? Because for lithium it will be Z, which is the number of protons, and they're telling you it has 3 protons and 4 neutrons. That is giving you 7. The atomic number is 7. So the explanation is because it is the sum of the number of protons and the number of neutrons. That will be the answer for 1.2. It is quite simple. Okay? Let's go to question 1.3. Now, question 1.3 said, this question deals with the periodic table of the elements. The letters used are not the symbol of the elements. Use only the letters given in the table when answering the question. So this is a piece of a periodic table. It is not the periodic table, it's just a small part of it, small portion. So just for us to understand what part is this one will correspond to group 1, this one will correspond to group 2, then it's coming the transition metals, all this area here. This is from period 3 to 12, then it is 13, 14, 15, 16, 17, and 18. Those are the groups, okay? And on the same point, we have here period 1, period 2, period 3, and period 4. So this is just to have an idea of what portion of the periodic table are we working with, okay? So, the first question here says, how many protons are there in an atom of element K? Remember, K is not a real atom, it's just a letter, okay? So, we have here A. Remember, the atoms are arranged by increasing atomic number. So, this one will have 1 atomic number, and this one will be atomic number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Those are the atomic number. So the atomic number, which is Z, is equal to 2, so that the element has 2 protons. Okay, let's go to the next question. Which element form an ion with a single negative charge? Now, all the elements in group 17, all these elements there will form an ion with the following way, which is -1. All of them will be -1. Okay, so that is important to recall. All these ones here in this specific group will form an ion of -1. All these ones here on this one here in group 1 will form atoms with the form of X's to plus. So all of them will lose 1 electron. And all the atoms in the second group, here, all the atoms there will form an ion equal to minus a positive 2, of 2 plus. Remember, by convention, we write first the number. So it's going to be 2 plus. All the atoms in this group here will form a 2 plus, all of them. Okay, so the question said, which element form an ion with a single negative charge? Is any one that is in group 17, but there's only one, which is J. So the answer is J. The answer is J. Let's go to 1.3. Which element has electrons in 4 energy levels? Remember now, if you want to know the energy levels, all the atoms in group 1 will have energy level 1s, or will finish in 1s. In period 2 will finish in 2s, energy level 2, orbital s. In period 3 will finish in orbital in energy level 3, orbital s. And the ones here will finish in orbital or energy level 4, orbital s. So this one here are the ones that give you the 4 energy level. So the answer will be D. So the answer for that question will be D. Question 1.3.4. How many neutrons are there in an atom of element J? Element J is this one here. Okay? Element J is that one. And they are telling you that element J has a 19.4 mass number. Like we did before here, in this question of mass, remember, for 1.3.4, let's do it here quickly. 1.3.4, you have the atomic mass is equal to atomic number plus number of neutrons. We are looking for the number of neutrons. That's what the question asking for. Neutrons is equal to A minus Z. Remember, this one is atomic mass, and Z is atomic number. So what is the atomic number for J? Remember, we follow here was 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it will be A, which is 19, is given to you. Is equal to 19 minus 9 is the atomic number. Once again, we start counting from A. 1, 2 with K, 3, 4, 5, 6, 7, 8, and 9. It has 9 protons. So it's minus 9, and therefore it is 10. Newtons. I really apologize about my voice. I cannot sort it right now, but I think it's important to carry on doing some questions. Question 1.3.5. What are the common names for group 1 and 2? Now, groups 1 and 2, this is what the question is this? 1.3.5. Groups 1 and 2 have common names, which you have to learn. Group 1 are called alkaline metals. All of them are called alkali metals, obvious, except hydrogen. And group 2 are called alkaline earth metal. Alkaline earth metal. And then final, they say what is the name of the group to which K and L belong. K and L is in group 18, and that is the noble gases. That is group 18, they are called noble gases. So these groups are important to learn, and this is all for now. I hope it helped. It is an important question. It is to practice for the upcoming control test, June examination, and etc. Thank you very much. Good luck, and I'm sorry about my voice.